Here we're being asked to combine the following expressions, and in this case we're doing addition and subtraction of radicals. The key for doing this is that you have to have like terms, which means that the values inside the root have to be exactly the same. Also, if you have a variable on the outside, like in number 2, those also have to be exactly the same. So in looking at number 1, I see that I have a negative 7 root 3 plus 10 root 3. What I look at is the root. And notice they both have a 3 in them. So in this case, they're like terms, so I can go ahead and combine by adding negative 7 plus 10, which gives me 3 root 3. Okay, so for the next one, number 2, I need to look at the same thing. Only this time, notice I have variables on the outside. So I need to make sure that those are identical. So I don't have a combination of, say, x and x squared, or x to the third and x to the fourth. In this case, I both have single x's, so those are like terms. So now I move into the root. And notice they both have root 2's. So in this case, I can also combine them. And I'll do it by adding the values on the outside of the roots. So I have x plus 3x, which is 4x root 2. Okay, so the next one introduces another thing that also needs to be the same. So I have 5's on the inside of each root, and I also have a fourth root for all of them. So all of those need to be the same in order to combine all of them, or at least, you could have a fourth root of 5 minus 7 times fourth root of 5 plus a different type of root. You'd be able to combine the first two, but not the last one. So again, my roots are the same. They're all fourth roots. They all have 5 in them, so I can combine. The first value has a 1 in front of it, so I have 1 minus 7, which is minus 6, plus 10, which is 4. And then I have the fourth root of 5. And that is my final answer for that one. All right, and number 4, the final one. Again, we have to look for, are the values in terms of variables on the outside identical? Also, are the roots identical? So in this case, we're dealing with cube roots because we have a 3 right sort of inside that root. So we have 2 cube roots, and then on the inside, we have the same value. So because the y's are identical, the roots, so the 3's are the same, and the value inside the cube root is the same, we can go ahead and combine these. So I get minus 5y plus 10y, which is 5y, cube root 7x. So notice that the values that are changing are the ones on the outside. They're the numbers on the outside, and then the roots stay exactly the same when you're adding and subtracting. Okay, here we're combining roots, but in this case, we're adding and subtracting roots that are not the same. So we need to figure out through simplifying whether they are the same or not. So I'm going to make a list first of perfect squares. So 2 times 2 equals 4. I'm not going to do all of them. I'm just going to get the list started. This is always a good thing to include when you're working on reducing radicals, which we have to do in order to do these problems. But basically what this is doing is it's giving you the list of numbers to look at in terms of what goes evenly into the values under the roots. Okay, so for the first one, I have root 32 plus root 50, and I started with perfect squares for my list because both number 1 and number 2 are perfect squares. Okay, so what I care about is whether any of the numbers on my perfect square list go into 32 evenly. Well, in this case, both 4 and 16 go evenly, but 16 is a larger number, so I'll have fewer steps if I use that one. So I'll go ahead and do the square root of 16 times 2. So I've just rewritten 32 using its factors. Okay, and then I am separating that, the square root of 16 times the square root of 2. Now, what is the square root of 16? Well, it's 4, so that becomes 4 root 2, and that is the square root of 32 fully simplified. Now I need to do the same thing for the square root of 50. So again, I go to my list and of perfect squares, and I see that 4 doesn't go into 50, 9 doesn't go in, 16 doesn't go in, but 25 does go in. So I can go ahead and do the square root of 25 times 2. This plus that I'm moving down is the one that was in the original problem. Now I separate those, and I get the square root of 25 times, let me do the same format as I did on the previous one, square root of 25, square root of 2. I'm going to drop the plus down again, and now the square root of 25 is 5. So I'm done with that one, and I have root 2 left over. So now I do have roots that are the same, so I can go ahead and combine. So I have 4 plus 5 is 9 with the square root of 2. So that is your final answer. Okay, so let's go ahead and do number 2. And again, it's the same process, only this time there are numbers already on the outside. So we need to multiply those in once we have our radicals simplified. Okay, so I'm going to go back to my list of perfect squares, and I'm going to say, is there a perfect square from that list that goes evenly into 12? Yes, 4 goes into 12, so I'm going to rewrite the root. So the 2 is this 2, and I'm just dropping that down until I need to use it. And it becomes the square root of 4 times 3. Okay, and then I'm going to separate that. So 2 square root of 4 times the square root of 3. Now I ask, what is the square root of 4? Well, it's 2, so I'm going to do 2. You need to remember that this is multiplication. So the square root of 4 became the 2, which needs to be multiplied by the original 2 on the outside. So now I get 4 square root of 3. All right, so I'm half done. Now I need to go back and do the 5 root 75. So I'm putting a plus here, and again, that's the original plus that I'm starting with. I have a 5, which I'm just going to have to drop down until I'm ready to use it. And then I look at my perfect square list and see, is there a number on that list that goes evenly into 75? Yes, 25 goes in evenly. So I do the square root of 25 times 3. I do plus, again, that's just the plus that was in the original problem along with the 5. Now I'm going to separate into 2 different roots, the square root of 25 times the square root of 3 plus the 5 that started in the problem. I'm going to do parentheses to indicate multiplication. And now I take the square root of 25, which is 5, and then I drop the square root of 3 down. Okay, so now I need to multiply the values on the outside, which are 5 times 5, which is 25, and then I drop the root 3 down. So notice now I have 2 terms, each of which have the same root, which is the root 3. So my final answer is 4 plus 25, which is 29, square root of 3. The instructions here again are to combine the following expressions. And once again, we have radicals in each of these, so we need to make sure that they're the same before I can combine them. So I'm going to redo that list, only this time I have a cube root and I also have a square root. So I'm going to do a couple from my cube root list, which again is 3, actually, I'm not going to start with that one, I'm going to start with 2. So I have 2 times 2 times 2, which is 8, 3 times 3 times 3, which is 27. Now I also have my perfect squares, which I'm going to include because number 4 is dealing with square roots. Okay, so those are my perfect cubes. And now I have 2 times 2 equals 4, 3 times 3 equals 9. 4 times 4 equals 16. And we'll call that good for now. And again, the part of the lists that we care about are the answers. The 8 and the 27, the 4, the 9, and the 16. Okay, so for number 3, I have cube roots, so I care about this list. My roots are not the same. The values underneath are not the same, so I need to simplify. Okay, so is there a list from the perfect cube? Is there a number from the perfect cube list that goes evenly into 16? 8 goes in, so I can rewrite as the cube root of 8 times 2. And then I still have an x cubed there, which again, I'm not going to address at this point, but I will in a moment. Okay, so now I need to separate those. So I get the cube root of 8 times the cube root of 2 times the cube root of x cubed. All right, so now what is the cube root of 8? Well, the cube root of 8 is the number you're multiplying together. So it's 2. Now the cube root of 2 does not have a cube root, so that has to stay put. But then I have the cube root of x to the third. Well, whenever your root and your exponent are identical, they cancel each other. So the cube root of x to the third is x. I've taken care of this part and this part. Those both will be outside of the radical. And then what's left is cube root of 2. So I've combined that. All right, so now I need to go to the next one, the x cube root of 54. Okay, so the minus that I'm drawing now is this original one. Now I'm going to write my x down, and then I have the cube root. And again, I need a perfect cube that goes evenly into 54. Well, 27 goes evenly into 54, so I get 27 times, and you multiply 27 by 2 to get 54. Now the subtraction sign again is the original subtraction sign from the problem. So here I have x, and that's just dropping down, cube root of 27 times cube root of 2. The subtraction sign needs to come down again. I am going to ignore the x for a second. I'm going to take the cube root of 27, which the number that's being multiplied 3 times is 3. So that simplifies down to 3. So I'm going to write 3. And again, that 3 corresponds to the cube root of 27. I drop the x down, and then I have the cube root of 2. So now I have an x on the outside of each of the terms that are identical. So based on that, I can combine, but then I need to double check that the roots are the same. So I have cube roots for both of them, and I have a 2 underneath both. So this is something that I can simplify. So I do 2x minus 3x, which is either negative 1x cube root 2 or negative x cube root of 2. Either of those are fine, although the bottom one, the negative x cube root of 2, you will see more often. Okay, so for the last one, again, we have roots, but we don't have the same roots. So as things are written now, we can't combine anything. So we're going to go through our process. Now I would recommend pausing the video and trying this problem and seeing how you do, and when you're done, going ahead and continuing the video. Okay, so the numbers that I care about for that 20 under the first root are from my perfect square list, because again, these are square roots that I'm dealing with. So is there a number from that list that goes evenly into 20? 4 goes in evenly, so I'm going to rewrite, and I'm just copying the 2 from here. That's going to drop down for the moment. Square root of 4 times the square root of 5. Okay, now I take the square root of 4, which is 2, so I get 2, and again, those are being multiplied together, square root 5. So now I get 4 square root 5. So that is the first term fully simplified with the outer value combined using multiplication. That's what the 2 times 2 is. Okay, so now I get minus, which is this minus, 3. Okay, I need a number from my perfect square list again. So is there a number from the list that goes evenly into 45? Yes, 9 goes in. So I get 3 square root 9 times 5. Okay, I'm going to carry the minus and the 3 down. I get square root of 9 times square root of 5. So minus 3 times 3 square root of 5. So I'm just going to drop the 4 square root 5 down because I'm done with that. So I have minus 3 times 3 is 9 square root 5. Okay, so I'm done with the first two terms. Now I need to do the last one. So is there a number that goes into 5 that is a perfect square? Actually, no, there isn't. So I just need to drop that value down. I can't simplify the square root of 5. So I get plus 10 root 5 plus 10 root 5 plus 10 root 5. Then I get down to the bottom one and I get plus 10 root 5. So do I have radicals that are all the same? I do. They're all square roots and they're all square roots of 5s. So now I can go ahead and combine. So I have 4 minus 9, which is negative 5 root 5, plus 10 root 5. That's this one. So minus 5 plus 10 is 5 with the root 5. And that is your final answer.